Hello students, in this video we will learn some new methods to solve non-homogeneous linear differential equations with constant coefficients. Now if we have this type of condition, then how can we evaluate particular integral for that? Let us discuss, and here the formula is 1 upon phi d square sine of ax. We directly put this d square is equal to minus of a square. This may be written as phi of minus a square sine of ax, provided this denominator phi of minus a square is non-zero. And similarly we have for cos ax, phi of d square cos of ax. So again we put this d square as minus of this value square. If it is a, then we put minus a square cos ax. Again, provided we have phi of minus a square is not zero. What will happen if this is equal to 0? That may be considered as case of failure. Case of failure. So as earlier, so in that case, how we write? We write phi d square sine of ax equals x 1 upon dy by dx of phi of d square sine of ax. And after taking the derivative, we again use this method. And similarly for cos, we will have phi of d square cos of ax equals x times 1 upon dy by dx of phi d square cos of ax. So after taking derivative, we again put d square as minus a square. Now let us see the application of these formulas in numericals. First numerical is solve d square plus d plus 1 times y is equal to sine 2x. So as earlier, we solve this in two parts. First, we solve auxiliary equation for the roots and write complement factor. Then in second part, we will find the particular integral. And at the end, we will join both solutions for the complete solution. So let us write here auxiliary equation is d square plus d plus 1 is equal to 0. So we have to solve this for the roots of d, and here we use discriminant method on 2. So which is minus 1 plus minus iota root 3 by 2, which may further be written as minus 1 by 2 plus minus root 3 by 2 iota. And very easily we can write the complement factor here. As we have complex roots, we write real part as power of exponential c1 cos root 3 by 2x plus c2 sine root 3 by 2x. So this is one part. Now for other part, particular integral is equal to 1 upon d square plus d plus 1 times sine 2x. So as we learned in the formula, what we have to do here, we put d square as minus of this square. What is here? 2. So we put d square as minus 4. So it becomes 1 upon minus 4 plus d plus 1 sine 2x, which is 1 upon d minus 3 sine 2x. Now how can we make this square here? Very easily we can multiply this with d plus 3 and divide it by with d plus 3. We can multiply as well as divide d plus 3. So this becomes d plus 3 upon d square minus 9 sine 2x. So again we put d square as minus 4. So d plus 3 upon minus 4 minus 9 sine 2x. So that is minus 1 by 13 times d plus 3 of sine 2x. And very easily we can apply this operator here. So this becomes d of sine 2x plus 3 of sine 2x. And as we know what is d, this is dy by dx. So we simply have to take the derivative of this, and which comes out to be 1 by 13 2 cos 2x plus 3 sine 2x. So which is the particular integral here. Now let us write the complete solution. Complete solution is y is equal to complement factor plus particular integral. And what is complement factor here? This one. So that is e power minus x by 2 c1 cos root 3 by 2x plus c2 sine root 3 by 2x plus particular integral, that is minus 1 by 13 2 cos 2x plus 3 sine 2x, which is the answer here. Next numerical, solve d square y upon dx square 2 dy by dx plus 5y is equal to sine 3x. Let us solve this. So first of all, we write it as, this may be written as d square minus 2d plus 5 times y is equal to sine 3x. And the auxiliary equation is d square minus 2d plus 5 is equal to 0. And we can easily find the roots here. So capital D is equal to, this is minus b, that is 2 plus minus under the root 4 minus 20 by 2. And after solving, this is 2 plus minus, this is minus 16, that is 4 iota by 2. And which will cancel, and we are left with 1 plus minus 2 iota. And very easily we can write the complement factor here. Real part is 1 e power x c1 cos 2x c2 sine 2x. So this is easy one. Now main thing is particular integral, and here we have d square minus 2d plus 5 times sine 3x. So using the formula, what we put here, d square as minus 3 square, that is minus 9. So it becomes minus 4 sine of 3x. And further, this simplifies to, we can easily take minus 2 common from here. So it is minus 1 by 2, 1 upon d plus 2 sine of 3x. So again, to make it square, we multiply and divide it by d minus 2. So here you see a plus b, a minus b. So it becomes minus 1 by 2 d minus 2 upon d square minus 4 sine 3x. So putting d square is equal to minus 9. So it is minus 1 by 2 d minus 2 upon minus 9 minus 4 sine 3x, and which simplifies to this is minus 9 minus 4 minus 13, and minus minus plus, this is 1 by 26, and we apply d minus 2 over here, so it is d of sine 3x 2 of sine 3x, and which further simplifies to 1 by 20x 3 cos 3x minus 2 sine 3x. So this is particular integral. Now the complete solution is y is equal to complement factor plus particular integral, that is we have this e power x c1 cos 2x c2 sin 2x plus 1 by 26 3 cos 3x minus 2 sine of x, which is the answer here. Let us solve a different type of question, that is solve d square y upon dx square plus 4y is equal to e power x plus sine of 2x. So very easily we can write it as d square plus 4 times y is equal to e power x plus sine 2x. So here auxiliary equation is d square plus 4 is equal to 0, which imply d is equal to plus minus 2 iota. And very easily we can write the complement factor here. What is real part? 0, and what is imaginary part? 2. So the solution is c1 cos 2x plus c2 sine 2x. Now the main part is particular integral, that is d square plus 4 e power x plus sine 2x. So very easily we can distribute this on both, that is 1 upon d square plus 4 of e power x 1 upon d square plus 4 of sine 2x. Let us separate them and solve separately. So first we solve this. So we write it here separately, d square plus 4 e power x, and we know the formula. We put the value of d, whatever be the coefficient of x here, and it is 1 here, so d is equal to 1. So very easily it is 1 by 5 e power x. So this is one part. Now we solve second part, that is 1 upon d square plus 4 sine 2x, and by the formula we put d square is equal to minus 4. What will happen here when we put 4 here, minus 4 here? So this is a case of failure. So as discussed earlier, we use the formula. So this may further be written as x times 1 upon derivative of this, and it is 2d sine 2x. So very easily, what is 1 by d? 1 by d means integration of this. So that may be written as x by 2 integration of sine 2x dx, and that will be evaluated to, and the integration of sine is minus cos, minus x by 2 cos 2x upon 2, which is minus x by 4 cos 2x. So combining these two results, this and this, so particular integral is 1 by 5 e power x minus x by 4 cos 2x. And the complete solution is y is equal to complement factor plus particular integral, that is c1 cos 2x, c2 sin 2x plus 1 by 5 e power x minus x by 4 cos 2x. So this is the final answer. I hope you got the idea. If we have sum of 2, then we will distribute it on both and solve them separately. We have solved this here and this here, and then we combined both to write particular integral, and complete solution is complement factor plus particular integral. This. Okay, let us solve another numerical, that is solve d cube plus 3d square plus 2d times y is equal to sine square x plus e power x. Let us see how we can solve this type of numerical, but before that we simply solve auxiliary equation, that is d cube plus 3d square plus 2d is equal to 0, and very easily we can take d common. This is d square plus 3d plus 2 is equal to 0, and we can easily factorize this, that is this is d is equal to 0 and d square plus 3d plus 2 is equal to 0, and d is equal to 0 minus 1 minus 2, and very easily complement factor is c1 plus c2 e power minus x, c3 e power minus 2x. Now main thing is particular integral, and here it is 1 upon d cube plus 3d square plus 2d times sin square x plus e power x. So as earlier, we will distribute this on both, and sin square x plus 1 upon d cube plus 3d square plus 2d times e power x. So we will solve them separately, and let us first solve this part, that is 1 upon d cube plus 3d square plus 2d, and very easily we can write the formula from trigonometry. Sin square x may be written as 1 minus cos 2x by 2, and again we will distribute this over this. So it is 1 by 2 1 upon d cube plus 3d square plus 2d e power 0x minus 1 by 2 1 upon d cube plus 3d square plus 2d cos 2x. So as by the formula, when we put d is equal to 0 here, this is a case of failure. So we have to take the derivative. Let us write it here, 1 by 2 x, and derivative of the denominator 3d square plus 6d plus 2 e power 0x minus, and when we put value of d square here, how much we put value of d square? Minus 4. So it is, so here we have minus 4d, and here minus 12 plus 2d cos of 2x, and here again we put d is equal to 0, so we are left with 2 only. So this is 1 by 4x, and here we have minus, so this is minus 4d plus 2d, this is minus 2d. Now let us write it as it is, minus 2d minus 12 cos of 2x Now again simplifying, taking minus 2 common from here. So minus minus plus 1 by 4, 1 upon d plus 6 cos 2x. To make it square, we multiply with d minus 6 and divide with d minus 6. So this is a plus b, a minus b. So we have 1 by 4 x, 1 by 4 d minus 6 upon d square minus 36 cos of 2x. So very easily we can put d square is equal to minus 4. 1 by 4x, 1 by 4 minus 4 minus 36 cos 2x. 1 by 4x, 1 by 160 minus here. So applying d minus 6 of this, d of cos 2x, 6 of cos 2x, which further simplifies to minus 1 by 160. And here we get derivative of cos is minus sine, minus 2 sine 2x minus 6 cos 2x. And this we can take 2 common from here, which can again cancel, and also this minus will cancel, plus 1 by 80 sine 2x plus 3 cos 2x. So here in this part we have got the solution for this only. Now let us solve this part. So that is, let me write it here, 1 upon d cube plus 3d square plus 2d of e power x. So we have to put d is equal to 1. So that is 1 plus 3 plus 2 e power x, which is 1 by 6 e power x. Now complete solution is y is equal to complement factor plus particular integral. So let me write here. So this is the complete complement factor. So y is equal to this plus this one, 1 by 4x, 1 by 80 sine 2x, 3 cos 2x plus 1 by 6 e power x. So this is the final answer.